You wake up, you check your phone, and you think you've just spent $78 overnight on AI just to get a single research summary. Now, most people think more expensive AI models are always better. But what if I told you that there's a $0 model that performs within 10% of the most expensive one? Here's the thing everyone gets wrong about AI pricing. You don't need to break the bank to get breakthrough results. I'm Evan Goldstein. I'm a licensed professional engineer and a data scientist. I'm building AI Capitalist R&D channel to talk to you about implementing AI in your business. So before we dive in, I know that this channel focuses on engineering and facilities maintenance, but the framework I'm about to show you works across every industry imaginable. Whether you're a lawyer sifting through case files or a doctor analyzing patient records, these exact same principles are still going to revolutionize how you approach AI tool selection. Stick around to the end because I'm going to show you exactly how to apply this to your specific field, no matter what you do. I love automate. So here's one that I made the other day that I've been working on. I call it Paperboy. It researches these feeds here for new papers that are being published in the field of artificial intelligence, scans them, and then it gets the most pertinent, the most relevant to what I'm trying to accomplish here. So things that are edgy or maybe show some new business use case or could be applied to things I'm already doing. Anyway, so in this case, it's grabbed 249 papers. It's running through each paper. I have an agent. This is an AI agent that I've built here, which just means an AI that can basically run tools and make decisions and do things in the real world. It's reading through all these papers and deciding which ones are keepers and which ones to toss. Okay, so as you can see, it's gone through 2 runs so far. It's already got 447 papers that it's found. Now, the idea here is that it goes through, then it selects the winner, and then on this side, it does a whole write-up on it, on the paper. It tells me what's my conclusion, what's the experiment really about, what were the researchers trying to discover. Anyway, that's not what I'm here to talk to you about. What I'm here to talk to you about is that I automated this. I ran it last night, and then I left it running. The idea is I wake up in the morning, I sip my little cup of coffee, and I read my paper. They spent $78 last night just on this stuff. Yeah, okay, that's not acceptable. I cannot be spending $80 to get one little write up on a paper. So there's a few ways to prevent this from happening. And number one is you can go into these language models and then you can just say always execute. Also within OpenRouter here, you can set limits to how much you're on any given model. So it just won't work after a certain point. However, I thought this would be a good opportunity to do some research on which models I should be using where. How do you get the most value and where do you apply all these different models? You've got ChatGPT, you've got Claude, you've got a bunch of freebies out there that work just fine. So when is it good enough to use a cheap model? Where's the best value and what is the best model for any application? And so I worked with AI and I developed this little schema for deciding, and I'm going to share it with you. Okay, so I set up an experiment here, or a research project really, where we're running different language models, and then we're going to do a comparison with the same context, so the same amount of data going in, that could be the same essay or the same research paper going in, and then we're going to see coming out how much each one costs and how they perform. And this is based on standardized benchmarks. So for the first use case we have is a rewriter or a voice transfer. The goal is to take a source text that's been written and to transform it into text that's a consistent brand voice, your voice, without losing the facts, the numbers, the quotes, or the attributions. This is going to use hard rules like no summarization. It's going to enforce a specific glossary, your lingo, and it's going to have a certain layout. Now, this could be a good idea for converting news articles into scripts. You can also turn technical memoranda into emails for narratives that you're ready to present. This could be used to standardize proposals. Okay, and in each case, I picked the best performing. So in this case, the best performing here is Claude 3.7 Sonnet. Performance is good. Cost is also the highest, of course. In this case, it's about 2 cents for 2,000, or sorry, for what was our context? Context was we had 3,000 in, 3,000 tokens in and 1,000 tokens out. Okay, so The Gwen 2.5 is the best value. You can see it's close. It's probably within a 10% shot of Claude 3.7 Sonnet, and it's super cheap. Limitation is, you see, this is the context window here, the 2000K context. You can send something huge to Claude. You can send about a tenth of that to Gwen. So not great. And the cheapest is Mistral. Mistral, this is some open, Mistral is an open source model. So AI router, open router runs Mistral itself, and they don't charge you to use that particular model. So hypothetically, you could set up an open router account and you could just run everything on these free models. They're not the best of the best, though. You can see there's probably about a 20% degradation in performance. Okay, next, agent tool use. So this is a case where agent, what we saw earlier. So in this case, we see an agent. Now this agent is, AI is running the show. So you tell it what to do. I give it its marching orders here. This is all the instructions I give it. And then it uses these tools one by one. Except there's a problem here. But it uses these tools off and on to, as needed, to accomplish the task that it's assigned. Not all AIs can do this. In fact, there's a narrow set of models that can do it. And the cheapest is Mistral Small. In this case, because I'm researching hundreds and hundreds of papers, this context window is going to be very limiting. So I would probably actually stick with Claude 3.7 Sonnet most of the time. But for most other tasks, I would do this Gwen 2.5. And then the cheapest is the free one. I might even just go with the free one. Okay, for classifier and triage. So what this does is it assigns labels or routes items based on the topic, the risk, the novelty, the urgency, ahead of other processing stages. What you would think of this is, if you would have an agent that's programmed to read your emails and respond, it has to decide, is this from a customer? Is this from an employee? Is this from a vendor? And route them on that basis. And then you could do it again, and you could say, is this an angry customer? Is this someone asking questions about a product? Is this a business question? All of these things can be handled by a classifier or a triage agent. The best here was 3.7 Sonnet, Gwen 2.57, and this one here is the cheapest, a 3.5 mini. Another task you use this for is extraction. You can use a large language model to put fields into strict categories within what's called JSON, which is a file format, like a text file. JSON is a file used to transmit information. So that would be like picking URLs, titles, abstracts, authors, and dates out of this mass of information that I scraped off of these feeds containing all the papers. We have the same sort of setup here. I would probably worry less about using Claude 3.7 because the cost is higher than using Gwen in this particular case. Once you've got the file, this is basically taking unstructured information and making it structured. Unstructured information is like comments on Facebook where someone is just writing without a standard. Structured information would be an invoice stating about this item for this much money with different fields. This is moving from unstructured to structured. I would use Gwen 2.5. Summarizers. We are trying to compress information while preserving all the numbers, quotes, and citations. This could be used for setting up executive briefs, newsletters, or research recaps. I would use Gwen. It's a lot cheaper. You'll notice some different models popped up here. This is the first Google model that we're seeing. So RAG is retrieval augmented generation, where you're using a large language model, but it's searching the web to grab information rather than just looking inside of its own memory. This can retrieve authoritative chunks, and it can answer with citations telling you where it got it. The success of this model would hinge on chunking or embeddings, and the context is really important. Gemini 2.5 Pro won out here. Claude Sonnet is more expensive. Gwen has similar performance. The context window is so small, you're probably not going to want to use it for that. Another option here is multi-document synthesis. You're taking different documents and trying to put them into one coherent picture, one brief. Compare the content, contrast the methods, and look at novelty or deduplicate overlaps. This would be good for a literature review or in business for doing a competitive analysis or novelty deltas and for comparing results to each other. Claude Sonnet 3.7 is the best performing. Slightly lower than that is Gwen, and the cheapest is 3.5. No surprises here. But I think I would go with Gwen. There's not a huge price differential, although this does have a larger context window, so you'd have to take that into account. All right, what do we learn from all this? Here's the big picture. Firstly, performance doesn't always correlate with price. If you want the highest possible output, you can pay for the premium model, but you can often get 90% of premium results at about 10% of the cost. Secondly, window size matters more than raw performance for document-heavy tasks. A lot of the performance we're talking about is really time. If I'm running this thing at midnight, I don't care if it finishes at 12:07 or 12:09, if it took an extra 20%. What matters is the output and the cost. In other cases, if you're looking at latency or the reaction speed, then you might consider some other criteria. For what we're talking about here, we can also see that free models can handle simpler tasks effectively, which makes them perfect for testing and development. Task-specific optimization is key to one-size-fits-all approaches every single time. Claude 4.1 is great, but when I assign it on every single little tool node that I'm using, it's going to wipe out the bank account. We also see that the best model can change depending on whether you prioritize performance or value or cost. What's really novel here is AI's ability to evaluate its own ecosystem. 6 months ago, we couldn't reliably get AI to run comparative analysis on AI models themselves, but now we can maintain consistent evaluation criteria across a lot of different complex task categories. The fact that we can automate this kind of meta-analysis is a fundamental shift in how we can approach technology decision-making. This example focused on an automation specific to writing tasks, but these capabilities go way outside of just content creation or literature review. And if you want more customized guidance for your specific industry and for your use cases, come on over to capitalist.biz. I do consulting work in the AI business space, and I can provide you with frameworks tailored to your situation. While these principles are universal, the details of implementation will make or break your success, and those are always specific to what you're trying to accomplish.